Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of synthetic division. What is synthetic division? Well, synthetic division is a way of dividing polynomials that allows you to basically do it in a much faster fashion. The restriction is that your divisor, the thing that's on the bottom, must be linear. Okay? So your dividend can be any old polynomial, just like we've been doing for long division. And your divisor, though, has to be x plus or minus a number, x to the first power. Okay? And the way you do it, this synthetic division, is you write down all the coefficients of your dividend polynomial without the x's. Okay? And then after that, you set this x plus or minus number equal to 0, and you solve and you get x equals some number, and that goes on the outside. And what you do is you bring down the first coefficient, it comes straight down, okay, and then you take this number times that, and that goes up here. Then you take your next coefficient and sum it to that product you just found to get the next term. And then you take the number times both of those, or actually it'd be just one number at that point, and then repeat the process all the way down to the last term, and you either get 0 or some number. And after you've done that, what happens is your answer basically has gone down by 1 power of x. You divide by a linear term, a linear binomial. So the easiest way for you to look at synthetic division is to just check out the examples. So I'm just going to go ahead and go into an example here. It's too short a video to do just a flat out example and concept video. So here's your first example we're going to look at, and basically we solve that x minus 6, set it equal to 0, and then that's going to go on the outside. Ooh, that was a very horrible line. Let's try that again. A little bit better. And then we write down the coefficients. There are none missing. Actually, no, the constants are missing, so we would put a 0 for constants. And then we bring down the 2. That one doesn't change. Then we do 6 times 2. That's 12. And then that comes over here, and after you put the 12 there, then you do 6 times 12. Alright, and when you do that, you're going to get a 72 there. Ooh, these numbers are not working out nicely. I guess I should have tried it before I went ahead and multiplied, or divided. So then 6 times 72, should have been x plus 6. Is that what it is? Did I mess up? I did mess up. I forgot the negative sign. That's what's wrong. Sorry. I thought something was just a little fishy. This is my 7th video of the evening. I've been working for about 6 hours. I apologize. Oh, that's basically what's happening in my brain right now. It's flipping on inside. So let's rotate it back. Alright, so take 2. If I bring down this 2, multiply, I get 12. When I add here, I get a positive 6. Then 6 times 6 is 36. And then when I add, something's still fishy though, it should be a factor, I thought. 2, and then minus 6, minus 18, that's right. 2, 12. Yeah, that's all right. So then we get a plus 18, and then 6 times 18 goes over here. So that's going to be what? 4. And then you add it together, and that's your remainder. So we would have 2x, it was cubed, so squared, minus 6x, plus 18, the remainder of 104. Okay. Let's try this one. Hopefully this one works a little bit neater. If we set it equal to 0, and then you put the coefficients, oh, running out of room there. So what I'm going to do, we know it's going to be x equals 2, right? So we put the 2 out front, write down the coefficients. Here we do have some powers that are missing. We have 0 for the cubed, minus 2, minus 10. And then 7 for the constants, bring that down, and we get to 10. 2 times 5 gives us 10. 0 plus 10 gives me 10. 2 times 10 gives me 20. 20 plus negative 2 is 18. Times 2 is 36. Added here gives me a negative, or I'm sorry, a positive 26. Times 2 gives me 40. No, can't multiply, can I? 52. And then when you add there, you're going to get a 2 and 45. Okay, and that's your remainder. So your final answer would be 5x cubed plus 10x squared plus a 18x plus 26, the remainder of 45, or you could say plus 45 over x minus 2. Okay? So synthetic division is not too bad. You're not always going to get a remainder. I just happen to pick 2 problems in which you do. So just practice a few of these. I don't think I'm going to do too many more examples of this. You'll see it again when we're doing our P's and Q's and division and factoring of larger ordered polynomials, okay? So you're going to need to know how to do synthetic division, so practice, practice, practice. Thank you and have a nice day.